right. So in the notebook that I'm in, I'm on page 137. Depends on what class you are in for what page number. But today we're going to be talking about circles that are not in the form x minus h quantity squared plus y minus k quantity squared equals r. Okay, that's what we talked about in the two previous lessons. When you have, well, let me write this. When you have a circle in the form x minus h quantity square plus y minus k quantity square equals r square, the radius and the center of the circle are very easy to identify. Oh, I forgot to give this a title. I'm going to call this circles in general form. Circles in general form. Yeah. And a lot of people call this form like center radius form, which makes sense. Center radius form. Because you can see the center and the radius just by looking at it. But different textbooks call stuff different things. Center radius form. But equations are often given in the general form of, y'all gonna think this is crazy now, ax squared plus by squared plus cx plus dy plus e equals 0. What? Ax squared plus by squared plus cx plus dy plus e equals 0.
Why don't we just
And my e, that's a cursive e. It's not the.
Why don't we just do like the whole alphabet?
I know, right? It's not the natural number e. It's just e. Okay. Now, when you look at an equation that's given in general form, you can't just look at it and figure out what the radius is and what the center is, okay? Now, remember, I was telling you on the review for the Liberal Arts Math 2 EOY, there were 2 questions on the review like what I'm going to show you today, all right? So it's important that we know this. And it's going to seem confusing at first, but it's not, all right? But at first, I'm going to write down all of the, directions on how to do it. Just chillax. It'll be okay. It's not as hard as it seems at first. Okay. So, like I said, when you're given an equation in the general form, you can't just look at it and see what the center is and what the radius is. We're going to have to do some work. Y'all remember when we learned how to complete the square with quadratics? Remember, when we learn to solve quadratics, we try to factor and then set the factors equal to 0, but not everything's factorable, right? So that method didn't always work. There's always two methods that always worked. Quadratic formula, which is what we always did, and completing the square, which we learned how to do, but we never used it unless we were told to, right? Well, on these, we're going to have to go back to completing the square to be able to solve these problems. So you know how to do most of this, it's just like putting it all together. Alright, so in my example, and leave yourself plenty of space to write the directions down the right side, we are going to find the center and the radius of the circle. Find the center and the radius of the circle. My equation is 4x squared plus 4y squared minus 16x minus 24y plus 51 equals 0. Well, do we have any like terms though? No. Okay. So, and you're like, what? We got x squares and y squares and x's and y's and... Alright, when you see a problem like this, you know it's a circle. You've got an x square, a y square, first of all. And you've got an x and a y also. And then we have this constant. Sometimes you'll have the constant, sometimes you won't. Okay? But if you have a constant, the first thing you're going to do is move it to the other side of the equation. Oh, we can do that. So move the constant to the other side of the equation. Remember, a constant is the number that doesn't have a variable, right? Constant, C-O-N-S-T-A-N-T. Move the constant to the other side. So, we can do that. Subtract 51 from both sides. So we got all this stuff we have to write again. So now we have 4x squared plus 4y squared minus 16x minus 24y equals negative 51. Mind's blown yet? No? Okay, good. Now the next step, you want to group your two terms with your x's together and the two terms with the y's together. Sometimes when you get problems, they'll already be like that, so you wouldn't have to go and regroup it if they're already grouped together. But sometimes, like in this example, they're not. So I'm going to group my x's together, and I'm going to put them in one set of parentheses, and I'm going to leave myself a space, because I'm going to complete the square, because I want to make it a perfect square trinomial. And then I'll add another parentheses where I'll group my y's together and leave a space, because I'm going to make a perfect square trinomial there too. Okay, so I'll do it first and then I'll write my directions. I'm going to group the 4x squared and the negative 16x together, and I'm going to leave a space for a constant, okay? Oh, I made a mistake. I'm not ready for that yet. Oh, that's okay, I left myself a space, but y'all may not have.
I thought you moved the 4x squared.
No, I forgot to divide every term by 4, actually. In these problems, your quadratic terms, your x squared and your y squared, the coefficient's always going to be the same in a circle. And if that's a number other than 1, we have to divide every term by that number. Okay, sorry, oopsie. So that's what I need to do before I group these together. So every single term, even on the other side of the equation. So I'm going to divide by 4, divide by 4, divide by 4, divide by 4, divide by 4. And sometimes we're going to have ugly fractions, and that is just the way it's got to go. Not always going to have pretty numbers. Hold up, let me fix my error. Hopefully y'all are writing in pencil.
Oh,
like all good math students do.
It's 1x squared plus 1y squared.
Hold up.
X minus 6.
Alright, so we got x squared plus y squared minus 4x minus 6y equals, and I'm just going to leave that as negative 51/4, okay? I'm not going to try and simplify that. I don't want a decimal. We'll just see in the end what we need to do to it, but right now just leave it as a fraction, okay? Now I need to write my directions. Divide every term, and I mean every term on both sides of the equation. Divide every term by the coefficient of the quadratic terms. Like I said, those will always be the same when you're talking about circles. I'm going to say it will always be the same coefficient for both terms. In this case, it was a 4. So now I'm going to group those x's together and those y's together. In the parentheses, leaving a space, okay? So I'm going to say x squared minus 4x. I'm going to leave a space for a constant. I need to make a perfect square trinomial, a PST, y'all remember. Plus, open parentheses, I know, y squared minus 6y. I'm going to leave a space for a constant, equals negative 51/4. Right on, Crouton? Okay, so do y'all remember when we make perfect square trinomials?
Nope.
Remember when you factor a perfect square trinomial, you get two binomials that are identical? Like x minus 2 times x minus 2, we would write it as x minus 2 quantity squared, right? So I want to make this a perfect square trinomial, and I want to make this a perfect square trinomial. So if you recall, to do that, we're going to take the coefficient of your x term, so like your b, you know how we have a, b, and c? You're going to take the b, divide by 2, and square it. Whatever that number is, you're going to add it to both sides. We'll add it here, and we'll add it here, okay? We need to complete the square in both sets of parentheses. So we do b divided by 2 quantity squared. So in my first set of parentheses, the x squared parentheses, a is 1, b is negative 4. We're trying to find c to make it a perfect square trinomial. So b is negative 4. So we do negative 4 divided by 2 quantity squared. Negative 4 divided by 2 is negative 2. Square it and we get a positive 4. Okay? So I'm going to add 4 into the first parentheses. So I added it to the left side. Don't put it in both parentheses, all right? I just add it to the left side, add it to the right side. I'm just going to make me a little running column over here. But if you don't add it to both sides, your problem's going to be wrong. Now in my second set of parentheses, the one with the y's, I got to complete the square as well. So I got to do b divided by 2 quantity squared. In this case, a is 1, b is negative 6, c is what we're trying to find to make it a perfect square trinomial. Okay, so we know we do b divided by 2 quantity squared. In this case, b is negative 6. Divide it by 2 and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9. I got to add 9 to both sides of the parentheses. So both sides of the equation. So I'm going to add it on the left side. I'm going to put it in this parenthesis. And then on the right side, I'm going to put it over here. So we made a perfect square trinomial. If I did the t-charts, a would be 1, b would be negative 4, c is positive 4. I need two numbers that multiply to get positive 4, add to get negative 4. If I did a t-chart, see if I could factor this. I would need two numbers that multiply together to get AC, which is positive 4, add to get negative 2, negative 2, right? So if we put that in factors, it'd be x minus 2 times x minus 2, right? Or we could just say x minus 2 quantity squared. Because we made a perfect square trinomial. PST, if you will. Since we know it was a perfect square trinomial, we know that we just make one set of parentheses, square it. The square root of the first term goes here. The square root of the last term goes here. And the sign of b is the sign that we use. Right on? Plus, we made another perfect square trinomial here. So you can either do the t-chart, or in our head, we know it's a perfect square trinomial, so we need one set of parentheses and we square it. The square root of my first term goes first. The square root of my last term, which is 3, goes last. And the sign of b is the sign in my parentheses. Equals, okay, negative 51 fourths plus 4 ninths. We're going to need a common denominator. Right on? Okay, let me do that real quick. So, negative 51 fourths plus 4 over 1 plus 9 over 1. Excuse me. What's my common denominator? 4. Sorry, I'm running out of room. So my first fraction, the denominator does the same, so the numerator won't change. Now in this fraction, 1 times 4 gave me 4, so 4 times 4, and it's a positive 16, right? And then in this fraction, 1 times 4 is 4, so 9 times 4 is 36, and that's positive 36. So I know my denominator is going to be 4. For my numerators, negative 51 plus 16 plus 36, and I get positive 1. So 1/4. Hey, look what kind of form it's in. X minus h quantity squared plus y minus k quantity squared equals r squared. Isn't that crazy? Yeah. What it says that my fractions? I don't know if how clear I can get it. I was just adding negative 51 fourths plus 4 plus 9 and getting a common denominator. So now that it's in that center radius form, can we answer the question? The question said, find the center and the radius of the circle. Can we? Isn't the center at h comma k? We got to change the sign of h and change the sign of k. So what's my center? Hello, hello, hello. What? Change the sign of h, change the sign of k. 2, comma, 3, right? 2, comma, 3. And then my radius, we know this is radius squared over here in this spot, right? So what's the square root of 1/4? What's the square root of 1? What's the square root of 4? 2. My radius isn't 1/2 times 1/2 1/4? Why, yes it is. So there's my answer. Center is 2, 3. The radius is 1, 2. Boom. And just like that, we're finished with this example, I mean. You may have a question? Wasn't too bad, was it?
Yeah, it was.
First time always seems the worst. Alright, I am on, in this book, page 138. This one will go faster. It won't seem as lengthy. It's got easy numbers too. Alright, this one says, what is the diameter It is. What is the diameter of the circle represented by the equation x squared minus 6x plus y squared plus 8y equals 0. Can I look at this equation and figure out what the diameter is? Or can I look at it and figure out what the radius is, first of all? No. Can I look at it and figure out what the center is? And I definitely can't look at it and figure out what the diameter is, right? But I can take it from this general form and put it in center radius form, and then I can figure out the question, okay? Just like we did on the last one. Now, on the last one, we started by moving the constant to the other side. Is that going to apply to this problem? No, there's nothing to move, right? Because this is 0. That would, if we had a constant, that would be your it. So that's already over there. The second thing we did is we divided every term by the coefficient of my squared term. So I've got a 1 and a 1. Do I need to do that? Divide by 1? Nope. All right, so that's good. And then we grouped our x's together and grouped our y's together. My x's are already grouped together. My y's are already grouped together. So we kind of skipped 3 steps right there. Okay? So in this example, I'm going to go straight to the parentheses. I'm going to do x squared minus 6x. I'm going to leave a space to put a constant because I want to create a perfect square trinomial. Plus y squared plus 8y. Again, I'm going to leave a space because I want to create a perfect square trinomial. So I'll do my x terms first. We got to complete the square. To do that, you do b divided by 2, quantity squared. What is b in my first set of parentheses? And it'd be negative 6, which no matter what, it's going to turn out positive, so it doesn't really matter if you put the negative in there. So negative 6 divided by 2 is negative 3, and negative 3 quantity squared is 9. So I'm going to add 9 to the left side of the equation and to the right side of the equation. Right on? So I created a perfect square trinomial, PST. Now look at my other parentheses, the ones with the y's. I need to create a PST here, so I'm going to do the same thing. I'm going to take my b, divide it by 2, and square it. It's 8 divided by 2, quantity squared. So 8 divided by 2 is 4, and 4 squared is 16. I'm going to pause this for a second. Alright, so where were we? Add 16 to both sides. And so I created a perfect square trinomial here and a perfect square trinomial here. I did that on purpose because I wanted it to factor into a binomial squared and a binomial squared so that I can get it into center radius form and answer the question. So here, I know this is a perfect square trinomial, so I can do a T-chart, but just shortcut, 1 parentheses squared. The first term is the square root of the first term, so we got x. The last term is the square root of the last term, so we've got a 3. And what's my sign going to be? Minus. It's whatever b is, right? So x minus 3 times x minus 3, if we FOIL that out, we get x squared minus 6x plus 9. Plus, we got another perfect square trinomial over here. So we know that factors into 2 binomials that are identical. So one set of parentheses squared. So it's y plus 4 equals, over here we just add 0 plus 9 plus 16 is 25. We now have the equation of a circle in center radius form. We can look at it, find the radius, we can look at it and find the origin, or not the origin, the center of the circle. So it didn't ask us, but where is the center of this circle?
-3.
What?
+3.
+3, comma, -4. Change the signs. But it didn't ask us for that. What is the radius? 5. So square root of 25. So the question says, what is the diameter of the circle? Is it 5? What? No.
Told you now. I told you.
A radius goes to the center, to the edge of the circle. What does the diameter do?
Go for the side.
Goes all the way. So what would my diameter be? 10 whatever units, right?
Hey, what you saying?
And there you go.
That's it?
That's it.
No more?
That one's a lot easier, right?
I guess.
All right, any questions? Anybody still writing? Once I push stop, it will not be able to see it any longer? Yes. Well, are we done with this? Okay.